before we get started, I want to get a feel for the group. So it makes resizing VIs a lot easier. I remember trying to screw around with resizing a VI before I started using subpanels, and it was a pain in the butt. So that's super nice. It also helps split up event code because each VI that gets inserted in the subpanel has its own event handler. So that makes your event block diagrams a lot nicer instead of having 40, 50 event types, which no one likes that VI. You can have much smaller chunks. Also, the subpanel chunk can be reused. You can take that inserted VI, use it somewhere else if it's written correctly. And then also, subpanels allow you to have very flexible code. You can insert different VIs at different times while you're running this thing and get totally different functionality. Some cons, okay, in general, you've got to insert that VI. You got to launch it asynchronously, put it into the sub panel, and then I don't need to show them here, but you also got to handle exiting that VI when the parent exits, handle messaging between the VIs. So it adds a lot of complexity. Okay, we got libraries, of course, which most of you will have used these before. Main pros of libraries, you get access scope. You can make certain VIs private, which is nice when you're creating an API because there will be supporting VIs that you don't want to muddy the waters with. So having that available is nice. You also get namespacing, and then in the Project Explorer, you can replace a library with a packed project library as well, which is nice for when you're switching over to something that's built. I'll also say, if you guys have questions along the way, feel free to ask them. Some of the cons, libraries don't really enforce anything to make your modules loosely coupled. There's nothing in there for that. You can call tons of other VIs that aren't included in the library. There's also nothing inherent that hides data from the user. And there's also, it doesn't do anything for simplifying your file system. It actually makes it worse. You add one more file to that pool of files. And it doesn't really lend itself to extendability by itself. Packed project libraries, pretty simple. You take everything that's in your library, you build it into a single lvlib file. The biggest advantage with this is that linking issues are pretty much non-existent when you build it into a library. It includes everything that it needs, including any dependencies it calls out of VI-lib, user-lib, whatever, which is super great for when you're distributing these modules around. And I'm a heavy user of test stand for the customers that I work for, and I would say if you're using test stand and you're not using PPLs, you're probably doing it wrong, and you should definitely look into this because it completely gets rid of the deployment utility, the test stand deployment utility from that use case. So just something to be aware of. It was actually designed for that in particular. So some of the cons with packed project libraries, any EXCs, DLLs, or other PPLs that you're using are not included inside that PPL. They all still work, but you just have to keep that in mind. And on the same lines, linking to other PPLs can get a little tricky if you've got a lot of hierarchy in your PPL structure. It's doable, but it might burn you initially when you start to learn some of the tricks there. You can, in fact, so I had to change this slide today because it turns out with LabVIEW 2019, you can actually go back from a PPL in your project to a library. This is a new feature that's come out in 2019. So it really shouldn't be in the cons anymore, but I didn't move it. And then just so you're aware, it's built code. It can't be modified, and it's built for a specific version of LabVIEW. This is a little less of a problem with 2017 and beyond because of the runtime compatibility stuff. If you check the right boxes when you build your PPL, it should in theory work going forward with newer versions of the runtime engine. Debugging is still possible. I'll bring that up in case you're not familiar with that, but if you include the block diagrams in that built thing, you can still do debugging and stuff, assuming you have the development environment on the machine you're running the code on. Okay, next we'll talk about classes. Classes kind of give you all the scoping benefits of libraries, plus you get a little extra. It allows you to do extendability because of the inheritance that's available there in classes, which is very powerful. You can include classes into libraries and PPLs as needed, making them private as well if you want to. You can also do data encapsulation. This is the biggest difference between classes and libraries. There are a lot of similarities. Obviously, there's inheritance, which is another huge difference, but being able to hide the data from the end user of your API is an important part of classes and their functionality. Some of the cons, when you initially start with classes, I remember being super annoyed just having to create data accesses all the time for things that I didn't really want to have to do that for. In the end, this is just something you kind of deal with and get over it and move on. Okay, so next level is actors. Okay, so judging from the group here, a lot of you haven't used actors or are not actively using actors. So the general synopsis here is actors are an asynchronous process that contains state information and can send and receive messages. So you can think of this as a class that is running asynchronously and that has messaging toolkit available for you. Okay, and actors are an extremely powerful tool. You get all the benefits of classes, plus you also add a messaging framework and tools to create messages, and it's super powerful. And also it makes running multiple threads super easy, and multiples of the same actor are trivial as well, which is super important. And then a lot like sub-VIs, it allows you to break code into smaller chunks. And that's what we're talking about here, is making modular code. So outside of just event handling, this also lets you break your business logic into smaller chunks as well. Making sure that your individual module is doing ideally one thing again. So the main con with actors, I would say, is that most people, getting started is difficult. Okay. And I actually, this is from experience here, not really on purpose, but I really didn't have applications for doing actors in the past, and so it wasn't probably 6-8 months ago or something where I really got a great project that I could just grab and jump into actors. And I will say, like, there were a couple little things, that I learned, and I actually have a slide on some tips that I learned, but I would encourage all of you to just jump in, feet first, get in there and start using them, because after you get over that hump, they're just an incredible tool that enables us to do incredibly really fun and exciting things with complicated UIs and complicated projects and all of that. So don't let this stop you. Debugging can be a little difficult, but as I showed on that earlier slide, we have a tool to help you with that. So don't really worry about this one too much. And in general, when you're doing actors, you're going to get a lot more VIs. Most of them will be simple VIs. You're going to have more classes and things like that. So, going from pre-actor, LabVIEW code, it is something that's a little odd, and something to get over. But again, at the beginning of this, we talked about making modular code, right? And one of the steps was you're making simple, smaller modules. So this is actually not really a con. This is what we're wanting. We want smaller chunks of code that are easier to debug and figure out. So, but this is something that initially when you jump in, it bothers you. But a lot of this stuff is scripted too, so it's super easy. And then usually, you have a launcher that will launch your root level actor. That's just kind of what's necessary there. But it's a fun place to put like a nice transparent picture, so you can make a really cool looking launcher. Okay, so like I said before, debugging is a little tricky with actors because everything's running is a clone, asynchronous clone. But at MGI, we figured out this problem pretty early on when we started using actors, and we developed the MGI MonitorDoctor. And this is a child class of the actor class. has some great debugging features. Okay, the pros of this tool, first off, it's free. So I think everyone can afford that. You get all the actor benefits, of course, but in the development window, you get this awesome pop-up window that allows you to see all the running actors. You get to see, their nesting hierarchy. You can open up any of the actors' block diagrams from this tool. You can debug, breakpoints, all that stuff's all possible in there. You can stop actors if you want. You can also, there's a message logging feature that you can turn on that allows you to see all the messages coming in and out of a particular actor, which is super helpful for figuring out what's going on with your actors. The only con I could come up with is it doesn't get installed with LabVIEW default install. So everything, one other thing I didn't put on here, but most of our tools, we strive to design them to be extendable. So like this UI, for example, is an overrideable class that you can basically, if you want to customize this UI and make it look different, do something different, you can do that. Okay? We try and design all the tools to allow that to happen because we understand there are use cases for that kind of thing. Are there any questions about MonitorDoctor? I'll show a little demo of this, but okay. So the next tool that we've developed for creating modular code is the MGI Panel Manager or Panel Actors. Okay, this is kind of an extension off of Actors as well, and it basically simplifies the creation of flexible user interfaces. And I'll show you some of that stuff here in the demo. Okay, it supports launching, inserting, removing, and stopping VIs either within subpanels or as dialogues. And like all the other tools, and like I mentioned before, this is extendable. You can create your own panels. I'm actually in the process of trying to create some test stand type panels for my use case that I will ideally be able to release to the community as well. But if you guys come across other panel types or other things that you need to create, we hope all the tools are there for that. Or if you have ideas on improving, of course, that's always something we're looking for. Again, it's free. And I talk about this can be used as panel actors. It can also be used with DQMH. There's a package for that. It can be used standalone. That's what the panel manager is. It's just some classes that you can enable. So if you're not using actors yet, you can still use panel manager as a nice flexible tool. It'll give you all the same ability to switch between the different types of user interfaces as needed. Really has all the pros of all the previous tools that we've talked about. And again, you can create your own panel types. The only real con, and this kind of applies to any kind of modular asynchronous code base, is that you have to deal with passing messages between these panel actors. But there are lots of tools for doing that and examples of different ways to do that, of course. Oh yeah, yeah.
I mean, that's the biggest one. I think that's what allows you to not recreate UI that otherwise in any other messaging that you use to do.
Yeah. So he's actually bringing up the tiered actors. So that is kind of one of the most advanced features of panel actors in particular. Basically lets you insert panels following your class hierarchy, which lets you do some really fancy things, which are really cool. And if we have time, I'll show you an example of that as well. Okay, so let me just pull up a little example here. For those of you who aren't familiar. Okay, so this is actually the shipping example project that comes with Panel Manager and Panel Actors. So I'm going to just show initially just this one composite user interface. Okay, so let me just go ahead and run this. And before I jump into the panel piece, this is the monitor window that, again, I showed just a screenshot of, that you can right-click on any of these actors that are running and show the actor core. You can enable message logging. There's also some stopping. You can do polling, different things like that, just for debugging purposes. Super powerful, super useful. All right, so the basic example here for this composite user interface, you can create some fake signals here. You can select however many you want and drag them over onto the graphs. So I actually modified this just before I came here. Anyways, you can have lots of different panels, different graphs. You can change the orientation of how this is all doing. Each one of these windows, that's an actor, and then each one of these graphs is its own actor. Everything's resizable as well. Okay. So I mean, this is a pretty simple example. But what I want to show you is how simple the actual code is for this example. So if you look over here in the project window, okay, everything under this for section here is that example, right? So there's actually 3 classes and I think 5 VIs total that enables all this functionality. And I'll just quickly go through the block diagrams just to show you how simple this stuff is. Okay, so this is the launcher. You're basically grabbing that root level panel object and throwing it in, giving it a name. Okay, there's a class here that lets you define where it goes, how it's shown and stuff. But I mean, that's super simple. And then if I jump into this is the root actor. You'll see again, this is the 4 subpanels on the front diagram with some splitters. Okay, this is what makes the resizing super easy. And then the actual example has this inserted as one of the panels. It's just a documentation. But let me just show you real quick how easy it is to change this. So this is just a different panel actor. If I want to replace that graph with this panel actor, I can wire that in, and I'll get rid of that change that I made when I was screwing around today. So I'm basically just taking this actor right here. This is a description actor with some text in it. It's getting put into a subpanel, and I basically array all these different actors and their associated panels together into one array and tell them all to launch. Okay, so I just made that quick change. Now instead of before having the 3 graphs, this is the way your example normally ships. There's some documentation on here that kind of gives you some instructions on how that works. But again, so I mean, this is flexible modules. You can put different things in where you need to. The other thing I didn't show, that I'll show real quick, so these panels are inserted into the sub-VIs, but there's also a button here. So if you want to pop that out, you just hit that button, it pops it out as a window. These are the exact same actors that are running in all of these cases. There's no change in any of the code that's running. And let me show you that real quick. So coming back to the code here, here's the data manager and its main actor core. So again, that's that left panel that lets you generate data sets and pop out that other window. So this is the most complicated of all the VIs here. I think you guys can handle it though. There are all of 5 events in this event handler. But creating new data sets right here, and then the one that's interesting here is when you pop that other graph window out, you're basically calling that same actor that you were calling it in the root level VI. The only real difference here is this function right here changes, okay, from going from a subpanel to a window, and that makes it pop out. So, I mean, it makes the code super flexible. There are modules that can be used in any kind of variety, any way you want. Okay. And then the only other code here is the graph. This is that panel, and again, I mean, there's nothing in here. There's a couple of events to handle dropping the signal types onto your VIs. So I mean, for me, like the take home here is just how simple this is to add all this functionality. Resizing, you didn't see any code for resizing, you didn't see anything really for handling popping the window out or putting it into the subpanel. All that stuff is hidden and included in the tools.
Is that a data set that you guys were how does it get the drag data?
So the drag, this is a fun example if you haven't done drag stuff before, but the drag happens in the from the data manager. So there's a drag started. Basically, it takes the data from the data manager, basically puts it into the drag queue, basically. So when the drag is received on the other end, it knows how to pull the data out. Anyways, I mean, powerful examples, but again, there are 6 different examples here that kind of show you all the key functionality for the actors. There's also examples for doing this as without actors, with just the panel manager stuff. There's examples. We have other packages for integrating into DQMH, as well as we have a couple of .NET packages for doing tabs with .NET, and also the MDI interface. Yes?
These examples, they get loaded when you install the toolkit?
Yes.
And what is the earliest version of LabVIEW this will work on?
I can't remember offhand. I know that some of the .NET stuff is newer than that. It has newer requirements than panels. I want to say, I don't know. Let me look that up, and I'll let you know.
2017, so for the .NET stuff.
The .NET stuff I know is 2017. I was trying to remember how much older you could go with the.
Yeah, I know it works in 2017.
Yeah.
I think the package only works in the IBM as well.
I think there's earlier versions, even if they're not necessarily on the package manager. I don't know how much earlier though. But I'll look that up for you, and you can come up and ask me afterwards. I can look it up quick for you. Any other questions about the example about panels and stuff? I would encourage you, yeah, to try this stuff out if you haven't. Okay, so some tips that I learned. As I said, I'm relatively new at actors in particular. First, just use MonitorDoctor for everything. There's really no downside, only benefits. And then if your actor has a UI element, it should really be a panel actor. And panel actors are MonitorDoctors as well, but that just gives you the flexibility. Even if you know you're going to put it in a subpanel, or you're going to use it as a dialogue, like just create it as a panel actor. You will have the flexibility going down the road if you ever need to change it up, switch how you're going to do it. The other thing that got me a number of times, it got me for a while, but when you're doing actors, there's an optional override that lets you handle the errors. So if your actor gets an error and you don't override this, the actor just closes. It's really weird the first time it happens. You're like, whoa, what the heck happened? So just be aware of that problem.
How does the MonitorDoctor interface with the NI scripting?
So in generally, we have an MDI tool that lets you basically switch between MonitorDoctor and the normal actor. But most of the time, we just basically create normal actors and then switch the inheritance after the fact. But that's what the tool is for as well. So
you're replacing?
We're not replacing it. It's just we're adding another class in between in the hierarchy, right? So instead of inheriting directly from actor, you inherit from MDI MonitorDoctor instead. Or, if you're doing panel actors, you inherit from panel actor instead. Okay. Yes. You do this once and you'll be burned. But yeah, do not try. There's another optional override called the pre-launch init. This allows you to basically set up your actor before you launch the actor. And you might think it's a great place to launch nested actors, and it is not. If you do this, it will not work. So don't try that. And then also, one of the things that you have to be aware of is you generally want your messages to be fast, because when you're in the message do method, you're basically locking up that actor. So if you're going to take a long time to do something, you need to be able to offload that to a different place. And that's why we have a bunch of the examples show you how to use helper loops. We have some documentation on our website about using helper loops. And that's basically anything that's going to be long running or take a lot longer. That's where you want to move that stuff over to. And then just in general, like one of the things that you learn over time is that because you're making much smaller or modular code, you're going to spend a lot more time in the project than you would normally in larger VIs with massive event loops and stuff like that. And it's a little weird initially, Your projects are a lot more complicated, but that's because you're making more modular, simple VIs, and that's where the structure and the layout is instead. Okay, so the bonus thing here, we're talking about module and package distribution. So that last little bullet on that Lego slide was you got to be able to share your modules. Okay, so what kind of tools do we have available for that? So if you wanted to, you can just copy the code manually, throw it up on a server, USB stick. Don't do this. It's wrong. You'll get by for a little while, but it'll burn you. And plus, people that aren't accessible won't be able to do it. Okay, so the basic standard tool for sharing code is VI Package Manager, and props for VI Package Manager, because before we had VI Package Manager, we had really nothing good. But it has some complications and some limitations. The first of which is packages are installed at the system level, which for us as consultants, this is a problem for us because we have lots of different projects, and some of them have different requirements and different, so it's very hard to keep your system in a state where you can do lots of different things. And so we've run into problems with this in the past, and so we kind of wanted to solve it. And also, like when your team building on a project, making sure that each of your systems is configured the same way with the same packages and everything. There's also no record of what packages are used. Whatever you have installed, you have access to, and you don't know for this particular project what you used in it. And it also is a little difficult for contributing to open source packages. A lot of this comes down to the fact that NI controls the submission, and I personally don't do this for more good ideas, but I know that getting updates to our tools that are on Tools Network is a bit of a pain, and it takes a lot of time and effort. So that's kind of a downside. The other tool that's been released is the NI Package Manager. This also installs at the system level. It's maintained by NI, it's closed source. I do love the fact that NI Package Manager allows you to define custom feeds, which is super useful for having your own local server or whatever, your own files that you can define. It is particularly great at distributing built binary code, and this is what you should use this tool for. In fact, we use it as well for this whenever we can. So at MGI, we figured, for all the reasons we've described, there's a bit of a problem with the package management that we had, so we've developed the G Package Manager. Okay, this is an open source tool to build and consume LabVIEW packages. It installs packages at the project scope instead of at the system level. So everything is installed in a subfolder right where your project file is. Okay. It also creates a package manifest file. So it's done in JSON, but it creates that file right alongside your project. It keeps track of all the dependencies, the versions of packages that you installed. All that information is right there in that file. So actually, you can restore package configuration really easily just with that single JSON file. So if you, for some reason, don't want to submit all your packages that you're using in your project with your project, you can just submit this one configuration manifest file, and then a single command on another person's system will go out and grab the packages, put them on in the same place, and everything will work. Okay. This was developed largely inspired by the Node Package Manager, which, if you're familiar with the JavaScript community, that's the package management system they use. I bring this up specifically to say that we didn't just start from scratch and kind of willy-nilly do this. We tried to look at what the other communities, other programming communities are using, and how we can leverage that kind of tool in our LabVIEW environment. Okay, we install it with NIPM because it's binary, and that's the way you should do it. And then just as a side note, like this works alongside VI Package Manager. So, it's a newer product. There's definitely not as much stuff on GPM as there is on VI Package Manager, but it allows you to kind of transition between the two as things continue to be added to GPM. Okay, so let me just do a little demo here of the website that we've set up. It's gpackage.io. Okay, so this is the website we've set up. So initially at the top there, you've got a couple of tabs to kind of show you different popular packages and newer packages that have been uploaded. There's some documentation on why GPM is the right tool for the job. And then down at the bottom, there's a couple of different ways you can install the packages or install GPM onto your machine. The most useful, I think, is just this one-line command line. Once you have NI Package Manager installed, you can literally copy and paste this into a command line, and it will install GPM on your machine. Okay, so and then at the top here, we can just search for a package, just to kind of show you. So again, we talked about actors, so, or panels. Let's do panel. Okay. Okay, so here there's 10 results for different panel packages that are up on there. You've got panel actors here, panel managers. So if I click on this panel actors package, all of these have nice documentation here to talk about how you use it. Okay, there's also links. Shows you dependencies here. Those are automatically handled. Shows you links to the open source repo for that package, and the licensing and all that stuff, changelog, all that's kind of included. It also shows you, if your command line bot, shows you the command line you need to install your package for the given project that you're using. But I'll stress that there's also in fact, I'll open it up here since we got a few minutes. There's also an executable that gets installed with GPM when you install it. Okay, so one thing to note, because this is project scope, when you open this GPM browser on your machine, it's going to ask you where your project is, because it's got to know where to install the stuff, right? So, so I'll just go ahead and put it here. This is the demo project that I set up. Okay, so this is the UI for the browser. Initially, you just get a list of installed packages if you have stuff installed. You'll notice that you click on any one of these, you're going to get basically the exact same stuff you see on the website, the readmes and the different license information, the changelog and all that. And again, the browsing here is it's all fed by the same information. I'll put that in. Nice, good job. Did not work. So again, you can search for different things. We're also looking at ways to improve this, having a list of companies that have submitted packages so you can easily browse and things like that, you know. But I mean, the main take home is you can create these nice simple modules, and then you can publish them. Actually, you can publish them right out of this UI if you want. There is no control. Anyone can basically go on and set up an account with GPM and submit packages that they want to submit onto the repository. There's some documentation on how you do that. But this is a tool that we solve a problem, and we're trying to solve it. But let me go back to the slides real quick. Okay. So I mean, the main take home here, we need help from the community, right? We're developing a project for the community, but we want your participation in this. This is pretty early beta software. But one thing to realize with a package manager and its involvement in your project is it's only basically installing the packages. Once the packages are on your machine, GPM doesn't actually have any involvement in your project itself. Those are just files that are on your file system at that point. So even if there is a little bit of bugs in how you get the stuff installed, once your packages are there, it's going to work great for you. I described my experience of jumping into panel actors and everything. I was also jumping into GPM at the same time and was installing all the panel actor and MonitorDoctor from GPM. And I really had no issues at all with it. So, but it's also on GitLab. So if you want features or you have fixes that you have in the works, we encourage you to get in there and take a look at it and try and add features to it. Fixes, so.
Report issues.
But
Or report issues.
Report issues, yeah, there's an issue tracker on there as well, so we give props to composite systems. They're actively using it and also submitting merge requests, so we appreciate that community involvement to make the project better. Okay, are there any questions about Package Manager? Yes?
So you're telling me that every time you use this, if you want packages X, Y, Z, it actually physically puts all the files used for those packages inside the project folder?
Yes.
So if I create a totally different project and I want to use those same things, do I have to download them again, or do I just copy them from somewhere else?
Yeah, I mean, you can manually copy packages from another project. But yeah, if you're using the normal user experience, yeah, it will download and install them again. This generally isn't a big deal because they're, most code modules are really small. That's not always the case, but in general that's the case. But I think one of the features that we would like to offer in the future is some simplified way to either show like your favorite packages that you use a lot and kind of have a simple command line or a button or something you click to say, all right, go ahead and install my standard packages to this library, right? So you don't have to go through and pick the ones you like. So that is a feature request that we've been mulling about in particular. So
what happens if you have two separate packages you're working on, or two separate projects you're working on simultaneously that may or may not use different variations of the packages or
it
whatever?
doesn't care.
Doesn't care.
You can have different versions of each package. You can have, it's all project based. So I mean, that's really the power of GPM, is that you can basically develop for a particular customer and their particular requirements and what they need, and then you're on some other project and there's some new version of some package you want to go ahead and give a try. You can upgrade that one on this project without causing any issues with this other project that also uses that same package. I mean, that is the reason why packages really should be installed at the project level and not at the system level, because they don't conflict with other projects that are using that same package. Yes?
If you have packages installed in the project and you want to see which packages use the manifest file,
Yeah, I mean, you can see.
GPM, or how does that work?
You can look in the manifest file. You can, the browser, once you select that project, you'll see it. So one of the features with GPM is when you install a package, it actually connects to the project and puts the project files, or sorry, the GPM packages in your project for you. So you will see a GPM packages folder in your project, and you can explore through there and see what's installed as well.
So
Yeah.
this question, the basic question, what happens if the project file gets moved, et cetera? Does that new question work in the browser?
The browser is populated by the manifest file.
Yeah.
So yeah, if you were to,
But if I go out and delete all that source and move it somewhere, then
So-
I'll tell the browser.
so if you delete the source, GPM doesn't really care, because that is a normal use case where if you were just if you didn't have your packages in source code control, you would just get the manifest file. There's a single GPM install command you can run from the command line that will basically go out, look at your manifest file, pull down all the packages that were installed in your project.
Yeah.
And so, I mean, are there ways to
It's
screw?
the other way around, getting a cluttered browser
Yeah, I mean, if
with stuff that maybe
yeah,
you
yeah, I
have a new
mean,
laptop, you move your source, you want responsible in your source code control, et cetera, et cetera.
so I mean, the main advantage of the way GPM is set up is everything's relative, though. So as long as you don't like you can move your project folder, your root level folder, anywhere you want on your system, and it won't care. Could you screw it up by like moving the GPM packages folder or renaming it? Yeah, I mean, you could probably do that. But you can copy that root level folder with your project in it anywhere you want, and all of that stuff will link up and work just fine. That's kind of the advantage of that.
So all the packages that you submit go onto your server?
Yes, they go onto the online repo.
Do you have any, so if a company wanted to have their own, is that a feature that you call?
That is definitely a feature we thought about, just having kind of a private server of packages. That is not currently implemented, but it is something we definitely want to do going forward. Is there another hand back? Okay. Anyways, go out and give it a try. There's a limited number of packages on there, but we hope that we can get everyone involved and start adding more stuff to that. Okay, so I don't know how many of you are aware of this, but in this room, they're doing this thing called a mini project track, I think is the right phrase for it. Basically, there's a MEMS microphone test system. There's actually hardware up here, and everyone that's in this room presenting is supposed to spend a few minutes talking about it and how what you presented on kind of applies to that project. Okay, so I talked about making modular code, so I'm just kind of gonna, loosely show you some of the code that they have, and then kind of talk about what I thought about it. Let's see. So first off, this got sent to me as a zip file. I extracted the zip file onto the hard drive, found a project, and I opened it up, and everything was broken, which was not a fun experience. So I managed to figure out, after a lot of finagling, how to get it to run. So this is the project file. I don't like that one. Get over here. So there's some examples in a virtual folder. There's a public API in a virtual folder, and then some private sub-VIs. If I jump back to the slides here, what do we talk about today? Like, how do you make modular code? There's the screenshot of what the project looked like when I first opened it. So first takeaway, I really dislike installing stuff in instrument lib, VI lib, and user lib, because they had different chunks of this code that was supposed to be in one and some in the other. And anyways, if you do that, you zip the file up, you send it to someone, none of it will work. None of the linking's right. So personally, I think you shouldn't do that. It doesn't make for nice modular code, okay? So there's not really any manifest that came with the zip file that talked about what packages were required, or what drivers or any of that kind of stuff, which wasn't very good. So I was a little disappointed that there were no classes at all in any of this code. And I'll show you some examples of kind of places where I thought that really they could use classes to make a better interface. And on the VIs I showed you, there was public and private, so they kind of had an idea for what they wanted. They wanted some access scope, but did they implement the access scope using libraries? No, they didn't. So I'm not really sure why not. And I'll pull up one of the examples. There's not really anything really done for modular UI. So I mean, I'm not trying to like dog them, because I don't know very much about this project, right? This was given to me a couple weeks ago. I haven't really had time to kind of dive into it. It's not my code. It's not my project. It might be a super awesome tool. But from a software design standpoint, when you're talking about modular code, this has a lot of mistakes as far as I'm concerned about how you would write this. So just as a little example, I actually took their code real quick, and I added a nice little library. I was able to mark the VIs they wanted private. So first improvement, that took me about 5 minutes. And then you'll also notice the examples are not part of the library. I did that on purpose. Then I'm making sure that the examples are actually using the API the way it was intentioned, right? You can't call any of that private stuff from your examples. So this is an one of the UI examples. Again, you'll notice nothing's resizable here. Nothing's really broken up. Let me show you the block diagram real quick. So you'll notice what looks like a really awesome application for classes, right? There's this sweet wire right here and this nice API with all this nice icon stuff. But that's not a class, that's just a cluster. So anyways, I think, the reason I bring this stuff up is because like I'm passionate, MGI is passionate about making LabVIEW a better community, making the code we write better just as a whole. So I want us to try and use the tools that are out there to make better modular code. Because as we use the tools that NI develops and that other alliance partners develop, if we standardize on those tools, it makes sharing code easier. It makes everything down the road easier. So I would encourage you all to try and just look and try and push yourself really. If you're not using actors yet, you're not using classes, you're not try and push yourself, find a good applicable project to try some of this stuff on. Go out and explore, get a feel for it, and I guarantee you, like once you get over some of the initial like learning pains, this stuff will help you. It will enable you to write faster, more modular code that you can share with other developers, and in the end, it'll be great for you. So, anyway, that's all I have. So, thank you for coming. If you guys have any questions, let me know.